Hello and welcome to Math World. Today we're going to pick up where we left off about exponent rules. So in our last lesson we learned the product rule that tells us when multiplying like bases you keep the base and add the exponents. Then we talked about the quotient rule where when you divide like bases you keep the base and subtract the exponents. So in this lesson we're going to learn the next three exponent properties. So the next one is called a power to a power rule. And this one's kind of interesting because in this case, we're going to have a base raised to a power. So for example, 4 to the second power, but it's going to be inside of a parentheses and then raised to a power. So we're going to have another power outside of a power. That's why they call it power to a power. So we're going to have 4 to the second power to the third power. And what happens to simplify this type of problem? We are going to multiply the exponents. That's going to be our rule here. Instead of add or subtract, we're going to multiply. So in order to simplify 4 to the second power to the third power, we're going to keep the like base. We always keep the like base of 4. And then we do 2 times 3. Because those are the two powers. We're going to multiply the exponents. 2 times 3 is 6. So my final answer will be 4 to the 6th power. It's very common for students to make the mistake and accidentally add these two, especially after we did the product rule when we were adding the exponents. But it's important to differentiate between the two. When multiplying like bases, you add the exponents, but when doing power to a power, you multiply the exponents. So there's the difference. All right, our next rule is probably the easiest rule, and that's when you have any non-zero base raised to the 0 power. So any number raised to the 0 power. So let's say the number is 90, big number, but I'm going to raise it to the 0 power. Anything raised to the 0 power is always equal to 1. And so this will be 1. And this works for anything. If it's 5 to the 0 power, it's equal to 1. Even if it's a variable, like x raised to the 0 power, I don't care what x is because it's raised to the 0 power, it must equal 1. So that's probably the easiest rule of all of them. Anything raised to the 0 power is 1. And our last rule is the negative exponent rule. This one's probably the most difficult. In this problem, we're going to have a base that's raised to a negative power. So for example, let's say I do 7 raised to the negative third power. So we have a negative exponent. Well, what we're going to do here is it's going to be equal to the multiplicative inverse. That means we're going to actually do the reciprocal and opposite sign. I know those are big words, but it means we're going to take this 7 to the third power and make it a positive 3. So 7 to the positive 3. And then reciprocal, we're going to put it on the bottom of the fraction bar with a 1 over it. I like this little hint. Cross the line, change the sign, slingshot. And all that means is if you have a negative exponent, you can cross the line, change the sign, and slingshot it to the bottom. It was up top, now it's on the bottom. Now this also works if you have a number already in a fraction with a negative. So let's say you have 1 over 2 to the negative fourth power. Well, we're going to make that 2 to the positive fourth power, but we're going to put it over 1. So instead of being on the bottom of the fraction, it's now on the top of the fraction. Which in reality, when it's over 1, you don't even have to include the 1. There's your final answer. So that's the toughest one because, we have to get rid of the negative exponent and put it on the opposite side of a fraction bar with a 1 over it. All right, those are our 5 exponent rules: the product rule, the quotient rule, the power to a power rule, the zero power rule, and lastly, the negative exponent rule. All right, well, that's it, and I'll see you in class.